Hello my precious friends, I really hope that you are doing great. Welcome to today's class. It's our 10th lesson on a given Form 2 mathematics topic called equations of a straight line. So we are looking at our 9th example, which is a past Kcse question tested in 1997, paper 1, question number 24. It reads that the coordinates of the points P and Q are 1, -2 and 4, 10 respectively. A point T divides the line PQ in the ratio 2:1. So part A of the question, we are required to determine the coordinates of the point T. So this is a question that is combining two concepts, that is the concept involving equation of a straight line and also vectors. So I'm going to highlight the key points which are given. I'm given the coordinates of point P, which is actually, so point P has the coordinates of 1, then comma -2. Then we also have another point Q on the other end, which is having the coordinates of 4, then comma +10. Then I'm told that a point T divides the line PQ in the ratio of 2:1. Remember, a positive ratio usually denotes internal division of the line. Therefore, if it is internal division, then the point T must be in between the points P and Q. Remember, if it was external division, then the dividing point will be outside that particular line. So I'm told that T divides the line PQ in the ratio of 2:1. So if this is T, then this will be the ratio 2, then this will be 1. So you just take the ratio of division in the order given. So T is in between here. Therefore, the ratio of PT is actually 2, whereas the ratio of T to Q is actually 1. So they want me to determine the coordinates of the point T. So here we are going to apply what we call the ratio theorem. For us to apply that, I'll create some vectors here. So I'll let these to be, I'll join them to the origin, that is the point 0, 0. I also join this to the origin, which is usually the point 0, 0, such that I'm going to create some vectors here. So this will be the vector OT, that is if I let this particular point to be O, then we will also have the vector OP, then we'll also have the vector OQ. Now, if I apply the ratio theorem, remember the ratio theorem dictates that suppose the first ratio is M, then of course this is the second ratio is actually N. The ratio theorem requires that if we take the vector that is the dividing point, which is denoted by the vector OT in this particular case, it must be equal to, we take the ratio M divided by the total ratio, which of course will be M plus N. Then when you take this particular ratio M, you divide with the opposite vector, which is vector OQ in this particular case. So multiplied by vector OQ, then we add, we take the second ratio, which is N, divided by the total ratio of the line, which is M plus N. Then when you are dealing with this particular ratio, you multiply with the opposite vector, which is actually vector OP. So this is what the ratio theorem dictates. Therefore, if I substitute the values given, I'll have a vector OT being given by, my M is actually +2, so I'll have 2 then divided by the total ratio will be 2 plus 1, which is actually a +3, then multiplied by vector OQ. Now remember, for the vector OQ in this particular case, OQ will just be denoted by the coordinates of 4, 10. Therefore, I'm going to write the coordinates in terms of column vectors. So this is 4, then of course 10. Then I add, my vector N is actually a +1. So I'll have 1 divided by a total ratio of this line is 2 plus 1, which is actually 3. Then this one should multiply with vector OP. Of course, OP will just be represented by the coordinates of 1, -2. Then of course, I'm going to write them in terms of a column vectors. So we have 1, -2. Now from this point, I'm going to open the brackets. So I'm going to get the following. So I'll have, of course, 2/3 is supposed to multiply each and every vector within the bracket. So I'll multiply with 4. Then I also have 2 over 3 multiplying the second vector, which of course is a positive 10. So this will be the first bracket. Then plus a third should also multiply the other column vector. So I'll have a third multiplied by 1. Then I also have a third multiplied by negative 2. Then of course these are column vectors. Now let me separate my working with this particular straight line here. So I'm gonna have the following. So if I open brackets, I'll have 2 by 8. Of course, that is 2 by 4. I'll get 8. So it means the vector OT will be given by, so this will give me 8 over 3. So 2 by 4, I'll get 8. So this will be 8, then of course over 3. Then I'm going to have the following: 2 times 10. Of course, I'll get 20. So I'll have 20 over 3. Then of course, let me elongate this particular bracket here. So this one should be under the bracket. Then of course, added 2. The second bracket, I'll have a third times 1. I'll just get a third. Then of course, this will give me negative 2 over 3. So negative 2, then of course over 3. So this will give me the following. So it is the same as saying we simply take 8 over 3. So this is 8 over 3. Then of course added to a third. So plus a third. Then on the lower side, I'll have 20 over 3. Then of course added 2. Positive multiplied by minus will get a minus 2 over 3. So this will be equal to 8 over 3. Then of course plus a third. The LCM will just be 3. Then of course 8 plus 1, I'll get positive 9. Then similarly here, the LCM will be 3. Then into 20 minus 2, I'll get positive 18. So this will be positive 18. It means that my vector OT will be given by the following. So if I divide through, I'll get the following: 9 over 3, I'll get positive 3. 18 over 3, I'll get a positive 6. Therefore, the coordinates will actually be 3, 6. So remember that coordinates must always be stated in horizontal form. Therefore, if vector OT is equal to 3, 6, it means that the coordinates for point T will be given by 3, then of course comma 6. So these are the coordinates of the point T. Then we check part B of the question, which reads that so B Roman 1. So in B Roman 1, we are told that find the gradient of the line PQ. So of course, to get the gradient of the line PQ, we just need to have the coordinates of the points P and Q. So let me sketch this particular line PQ here. So of course, we have this particular line PQ. So on one side, we had the coordinates of point P. P was given by, let me refer back, P was 1, negative 2. So this is 1, then of course negative 2. Then Q had the coordinates of Q is 4, 10. So this is 4, then of course 10. Then we are having this particular point T, which is dividing this particular line, whose coordinates we found coordinates for T to be 3, 6. So this is 3, then of course comma 6. Now they want us to find the gradient of the line PQ. Now we know that for us to get the gradient, we'll need the change in y over change in x. So I'll let this to be my x1, then this to be y1, then of course this to be x2, then y2, because they want the gradient of PQ. So I'll say that the gradient of the line PQ must be given by y2 minus y1 over x2, then of course minus x1, which will be given by my y2 is positive 10, then minus y1 is negative 2, then divided by my x2 is actually positive 4, then minus x1 is 1. So this will be given by negative will be plus, so this will be 10 plus 2, which is 12, then divided by 4 minus 1, I'll get positive 3. Then of course 12 divided by 3, I'm I'm going to get positive 4 as the gradient of the line PQ. Then we move to Roman 2 of the question, whereby you are being told to hence. So hence means that we use the result that we have gotten in A. Therefore, we need to use this particular gradient. Hence, determine the equation of the line perpendicular to the line PQ and passing through the point T. So we are having another line which is perpendicular to PQ but through the point T. So we have a perpendicular line through this particular point. So of course we know that for any two given perpendicular lines, the product of their gradients should actually be -1. So if I let this coordinate to be S, therefore it means that the line PQ and the line TS will actually be perpendicular to each other. Therefore I'll say that the gradient of the line PQ multiplied by the gradient of the line TS should actually give me -1, since the two lines are perpendicular. Therefore I'll say M1 M2 should give me -1, where M1 is the gradient of the line PQ. So the gradient for line PQ is 4. So I'll say 4 multiplied by M2, which is the gradient for the line TS, should give me -1. Then of course I'm going to divide through by 4 so that I get the gradient for the second line. So I'm gonna get the following from this particular working. So if I divide through by 4, divide through by 4, the 4 and 4 will cancel out. Therefore the gradient for the line TS, which is actually M2, will give me -1/4. So having the gradient, we can easily determine the equation. So the equation for line TS will be given by the following. So we know that we have two coordinates here. We have T, which is actually 3, then of course comma 6. So to get the equation, I'll also introduce another point x, y, such that I let this one to be my x1, then of course this to be y1, then this to be x2, then y2. So we know that the gradient for the line TS must be given by y2 minus y1 divided by x2 minus x1. So this will be given by, the gradient is -1/4, so I'll have -1/4 being given by y2, of course, is y, then minus y1 is +6, then divided by my x2, of course, is x, then minus x1, of course, is +3. Now on cross multiplication, this one will multiply with -1, then of course 4 will multiply with this part. So we'll end up with a -1 into bracket x minus 3 being equal to +4, then of course into bracket y minus 6. Then of course I'm gonna close the bracket. So if I open brackets, this is what I'm going to get. So I'll get the following. So I'll have -x, then of course -1 times positive that times -3, I'll get a +3 being equal to 4y. Then of course 4 times -6, I'll get -24. On collecting the like terms, I'll take this one towards this side, so that I end up with -x, then of course +3, then +24 being equal to a +4y. So this will give me -x, then of course a plus 3 plus 24, I'll get 27 being equal to 4y. Therefore the equation can be given as, I can take this towards the right hand side, so that I end up with 27 being equal to a +4y, then of course plus x, which can be rewritten as x plus 4y, of course, is equals to 27. So this is the equation for the line TS, which is the a line perpendicular to the line PQ, but passing through the point T, which has coordinates of 3, 6. Then we check Roman 3 of the question, which states that if the line meets the y-axis at the point R, calculate the distance TR to 3 significant figures. So I'm told that the line is actually meeting the y-axis. So if I let this to be my y-axis, then I have my x-axis here. So if this is my x-axis, then of course this is my y-axis. It simply means that the line is cutting through this particular axis in this particular manner. So it's the line is passing this way, such that the point of intersection of the line with y-axis is actually the point R. So I'm told that if the line meets the y-axis at R, so of course for this particular point R, along the y-axis, the coordinate of x is always equal to 0. Then the same line is also passing through the point, because it is TR, it means that the line is also passing through the point T. Then of course, our coordinates for point T were actually 3, 6. So this is 3, this is 3, then of course, comma 6. So we need to find the coordinates for the point R. Then of course, we also have the equation for the line TR. We found this particular equation in B Roman 2, such that the equation, that is the equation for the line. Let me see. We already had the equation for this particular line, which was 4y. So we had the equation was actually x plus, so we had x plus 4y, x plus 4y must be equal to, x plus 4y was equal to 27. So this was equal to 27. Now, we need to find the coordinate for the point R. Now, we know that at the point R, which is actually the y-intercept, at point R, which is the y-intercept, the coordinate of x must be equal to 0. Therefore, the equation x plus 4y, x plus 4y is equals to 27. If I substitute with x being equal to 0, I'll end up with 0 plus 4y, of course, will be equal to 27. So this one means that 4y is equals to 27. So if I divide through by 4, it means that the y coordinate at the point R will be given by 27, then of course over 4. So this coordinate is 27 over 4. So that is the coordinate for the y coordinate for the point R. Now, having found the two coordinates, now we can actually answer the required question. So we were required to find the distance of TR, that is the distance of TR. So to get the distance, we are going to apply the concept of vectors. We simply find the magnitude of the line TR. Now, for us to get TR, of course, I'm going to create some vectors here. So let me join this particular point to the origin. So if I join this to the origin, it means that we are going to have the two vectors. If this is the origin, we have vector OR and also vector OT. Such that if we want to find TR, we are going to talk of the following. So TR, vector TR will be given by, so to get TR, we'll just take OT. So TR will be TO. We simply take the vector TO, or simply you need the coordinate of R, then you subtract the coordinate of T. So this is OR, then of course minus OT, OR minus OT. So this will be given by the vector OR will be given by the coordinates for point R, which is actually 0, then 27 over 4, 0, 27 over 4, then minus the coordinate for OT are simply 3, 6. So this is 3, then of course 6. So if we subtract, we are going to get the following. So we'll end up with 0 minus 3. This will give us negative 3. Then of course 27 over 4 minus 6, the LCM will actually be positive 4. 4 into 4, 1. So I'll end up with 27 minus 4 multiplied by 6. I'll get positive 24. So if I simplify, I'm going to get the following. So this will be negative 3. 27 minus 4, I'll get a positive 3. Then, of course, over 4. So these are the coordinate for the point, that is the vector TR. Now, to get the distance is just the magnitude. So to get TR, the magnitude for the vector TR will be given by, you take the x coordinate squared, then of course plus the y coordinate squared. Of course, this is the x coordinate, then this is the y coordinate. So this will be given by the following. So the magnitude of TR, or simply the length, will be given by, we take the x coordinate squared, of course, which is negative 3. So we'll have negative 3 squared, then plus the y coordinate squared, which is 3 over 4. 3 over 4 squared. So this should give me the magnitude or the length of the vector TR. So this will be given by the following. The root of negative 3 squared, I'll get a positive 9. Then, of course, plus 3 squared, I'll get 9. Then 4 squared, I'll get 16. So this will be given by the root of. So here, if you add this particular 2, if you take 9 plus 9 over 16, you feed this on your calculator, you're going to get 9.5625. Therefore, the square root of this, correct to, we wanted the answer to 3 significant figures. So the square root of this will give you 3.09. So this is correct to 3 significant figures as required by the question. Thank you very much for accompanying me until the end of this particular lesson. I do not take it for granted. In case you are new to the channel, kindly hit the subscription button and also turn on the notification bell so that whenever I upload a new video, you'll get notified. Until next time, this is Kind Tuition Academy. Thank you very much.